there any questions?
Can we use Java's built-in utility for the queue interface, or should we write our own queue interface?
So the question is, can you use Java's built-in queue interface? Or should you write your own? What difference does it make? Anyone? You all understand the question? Or at least the Java people understand the question?
So the queue interface that you're implementing from Java probably has other things that it's also right? But if you create your own, then you're losing some of that. Does that make sense? I don't know if I wrote that well.
So one comment is you might lose some of the things that the existing one already has, right? Well, you could always add that to your interface, right?
Yeah, because I guess I meant more like the things that it's the queue interface inherits from something else, perhaps. I don't know.
Yeah, and why might that be important?
Well, like,
users to be able to put ours right where it belongs in the hierarchy. So if you need to, you can above it.
And why did I ask you to put it in where it belongs in the hierarchy?
Because this is a common thing that we're going to be doing, is creating generic interfaces in industry, right? So the more that we map it to what's in the library, the easier it is for everybody else to design into it, right?
So that's one part, is that once you fit in, it's easier for anyone else to use it, right? That's the same reason I gave, why do you want to use standard names, right? Why use size in Java instead of get size? Well, because all the classes existing, all the collection classes use size, right? But there's also another important reason.
does it have to do with the functions on the board?
No.
So you can like use MapReduce and filter on the collections that you're adding to the library?
Well, okay, it's related to that.
Unless you, I guess, extend that queue to be sort of an abstract collection.
Yeah, if you're starting to get to the point, right? I mean, look, if I have some sort of, function foo, right, and I have an argument of type qx, when I call that function, what can I pass in? Anything with a queue interface, right? Which queue interface? Right? So if you write your own queue interface, then it's completely separate from their queue interface, right? And so any code that uses their queue interface, you can't stick your queue in, and vice versa, right? But if we use the built-in queue interface, now I can any subclass I build, I can pass in here, right? And any Java, right, subclass, I can pass in here, right? And since they both implement that same interface, then, and the function assumes it, it'll work, right? when we talk about, one of the benefits of object-oriented programming, someone mentioned polymorphism, right? What does polymorphism mean? It means, polymorphism, the words mean many forms, right? Which basically says, look, I can have different objects of different classes that I can basically respond the same messages, right? So I can interchange them. But in Java, that's all tied up in the class hierarchy and interfaces, right? So if we want polymorphism, I want to be able to pass in an object and have it respond appropriately, like I do here. It's all tied up in the type, right? And so if we want polymorphism, and we'll see as we go forward what various places are less useful, right? We need to make sure that, right, we've got a parent class and interface that things implement. Now Python's different because it's not strongly typed, right? And so all you really need to know is that, when you you basically don't declare the type, right? So you just need to make sure that whatever you pass in there implements the methods that that function requires, right? So the Python story is a little bit different, but and you have to think in the head, right? So if you start building separate random classes, you're never going to be able to interchange them because they're separate, right, random classes. Any other questions? So we were talking about, right, all this filter, map, collect, right? Different languages, different iterators. We talked about Python. These are very, very common functions these days, and you should be comfortable trying to use them. Can you pass functions as arguments to map?
Or like a specific operation that you want to occur on everything in the list beyond +1, +2, like something complicated.
Well, let's see. Do I do map someplace? Filter. Well, here we can. You mean like this?
Yes.
Yes. Different languages have different versions of this. Python's, of course, is different than Java's. But yeah, that's usually what you end up doing is in reduce, it's first initial value and then a function which tells you how to deal with combining things together. Right, with map, it's okay, usually pass in a function which tells you, right, how to transform each element. Now, often it's a lambda you pass in, but a lambda is still a function, right? It's just a function without a name. So you don't have to declare it separately because often it's a very simple function. Maybe I just want to add 10 to each element. Well, then it's just element plus 10. So why do I need to declare a new function just to add 10 to something? So we use a lambda. So various use the reduce, filter is just, right, is just selecting them, right? Make things true. Map, it just transforms the element, right? And the syntax is Swift, is not Java, but
So these are all changes to the actual array, not like copies.
so yeah, the question is, did you change the actual arrays or do you make a copy, right? Again, that depends on the language. In Java, the way you do it is you create a stream, and then you're building up a stream, right? In Swift, what you're doing, you're returning a new collection, not modifying the existing one. Given that Swift is very concerned about mutability, it's not likely they're going to want you to always modify the existing one. So there's a couple more design patterns to talk about for your assignment, and one is a command, right? Encapsulates a request as an object. Yeah, let's. Yeah, one motivation for a command is, let's say I want to implement undo, right? And you're all familiar with applications that have undo in them, right? Control Z, right? And then, you also have, usually there's redo, right? So when you undo a couple times, then you can redo it and go back, right? How do you implement that? Well, what do you need to know to implement that, right? You need to know what the operation was, and you need to know how to reverse it, right?
Or you can just save the state.
Or you can save the state and copy the state each time you do an operation. But you need to know every time you do an operation to save the state, right? And so there's two design patterns we'll talk about that support undo. One is a command, and one is a memento. The memento is the one that saves the state. The command doesn't necessarily save the state. What the command does is, I need to know, you need to know what thing you're going to change, and you need to know how you're going to change it, right? And you also need to know how to reverse that change, right? And so what we need to do is, well, I need to know what I'm going to change. So I need to store that as state, right, in my command object. And then I need a couple methods called maybe execute and undo. And the execute knows how to actually perform that operation on the object I want to change it on. And then the undo knows how to reverse that operation. And then what you need to do is, instead of calling the operation directly on what you want to change, you create a command object, you pass in, here's the thing I want you to change, right? And you build a command just to make that particular change, right? And then I can call execute on it, and then I have to take that command object and put it in a stack someplace so that when you do Control Z, you can pop things off the stack and then call undo on it, and then you put it on another stack, because when you want to do redo, right, you have to pop it off this stack and then call undo on it and then put it back on this stack again, right? So far, so good. So the command object needs the thing that is going to change it, and then if you want to undo, you need two methods, right? Execute and undo, and those two methods have to know how to perform that particular operation, which means for each operation we perform on that thing, we need a separate class, right? Because execute and undo are then specific to each type of change you want to do.
So a command has to have both undo and redo.
Only if you want to support undo, right? There are other reasons why you might want to do this. You may want to delay, right, the operation until some future date. That happens a lot. We call them callbacks, right? Although callbacks has slightly different properties. We might want to create a little language, right? And so each command can be part of the language, and then we can execute all those commands. Maybe you want to do it in a batch job, right? So there are various scenarios where you might want to use commands. And not all of them require undo.
So what is the big picture of command pattern? Where is it significant?
Is it significant?
When is it significant?
One big use is when you want to support undo, and you don't want to copy the state over and over again, right? There are times when you want to delay execution, and a very common case of that is callbacks, right? I've got a menu or a button, and when you click on the button, something should happen, right? But you don't want to create a special button class just for that particular operation. You want to tell the button, here's what you do when you're clicked on, right? And so now the structure, right? Well, so we have some sort of command. You're only showing execute because if you're not supporting undo, then that's all you need. And that's some sort of interface. Why? Because you might have multiple types of commands you want to execute on the same thing, right? So you need a separate one for each one. And then that concrete command has a receiver. That's the thing you actually want to change, right? Modify. And, then the execute method that does something. It calls a function on that particular object. And what this does is it's a standard computer science trick. We add a level of indirection, right? So instead of asking him to do something, I ask him to tell him to do it, right? In this case, the level of indirection is done so that we can postpone it to some later date, like a callback, or if we want to support undo, we can then later have all the data we need and to actually undo it. So far, so good.
So we are thinking that to delay an action we can use this pattern, but the undoing part won't come there in that case. Right? You just
Say that again, I can't.
so these two are different things. For redo, for redo and undo, we can use this pattern, and for delaying action, so
Yeah.
we don't have to consider undo this.
Yeah, if you just want to delay it, then you don't need the undo, right? And that's one of the things about the design patterns is that you don't necessarily repeat them exactly each time. You have to adjust them to the situation at hand. And so when design patterns started being really popular, the IDE started building in ways of actually generating each command, each pattern. It's like, and people are going, well, that's stupid because you're creating boilerplate code that's identical each time, and you may not want all those features each time. So why are you even bothering with these boilerplate generations? And that has died down somewhat. You don't see that very as much. Um, so a typical example of what I'm doing is like we're typing text, right? And the problem with typing text is, I mean, you can move the cursor, type here, move the cursor, type here, and then when undo, it's like, oh, if I want to do it, I need to know what was typed and where it was typed, right? And so in that situation, we need to store more information than just, we need to know the text document you're typing in, whatever data structure that is, and we need to know where in the document you're typing and what text you're typing and maybe even the font information, right? And so there's more information you need to store than just the receiver, but it has to be stored because what I want to do, I need to know, okay, it's this text in this location and this font information has to go away. And when I redo it again, I know where to put it.
The undo function makes a lot of sense if you're thinking about it in terms of a stack, but since this is priority queue, like, are we going to have to track the changes in order with the secondary data structure, or like, or is that like not quite what we're talking about at the moment? I'm trying to think about how to do this. I get a context of the assignment.
Well, what types of things you need to worry about in the priority queue in terms of undo?
Add, remove.
Add and remove, right?
Right. So I guess with the undo, you probably just want to undo the object that you most recently added, because I think it's like a this thing and this thing and this thing and this thing all the way back to the no changes forever, and then redo is just do it all again. So okay.
So you're good?
I think so. I hope so.
So in your example code there, the client kind of has to do all the executing and moving. I guess that makes sense, but Yeah, we can't keep track of changes or anything unless it's through the client.
That's an excellent question. And to make sure everyone pays attention, there's a potential for losing points on your assignment, right? Where do you keep track of all the changes, all the command objects?
Structure class, presumably, right? That'd be the most obvious place to do it.
One obvious place to do it in the data structure, right? Which means you create a stack, right? And you store things in that stack, right? And what are the consequences of doing that? Use of memory. So what if I have a long-running program, say running, I don't know, days, weeks, months, and use a priority queue, and you're continually adding things to the priority queue and continually deleting them. What's going to happen to memory?
It's gonna grow, but I mean, it depends whether or not what you're storing in the stack, right? Because I know in Java there's a function called hashcode that you can use that'll give you with a reasonable but not perfect level of certainty that it'll be a suitable unique ID for any given object that you insert into the queue. So if you just keep hash codes in the stack rather than a complete copy of the object, you're going to cut the amount of storage space that you need, like by an order of magnitude. I think it would just be a bunch of integers.
Well, but you need to know what you added, right?
Right.
When
So,
you deleted, and that could be garbage collected.
Okay. Yeah. Okay, that makes sense.
And in Java, let's see. Does anyone know the overhead for an object? How much memory? What's the minimum memory used in Java for an object?
8 bytes, according to the first thing I googled.
That actually seems low to me.
Let's see.
And what if in this long-running program you don't care to support undo? And your priority queue internally is keeping the stack of the last, well, I don't know, 100,000 adds and removes. How much memory have you just consumed?
So then the solution just got a limited stack. Like most programs don't let you go like all the way back to the beginning of a complete command string. You'd have like some reason, like 50 commands or something, or even less.
And what's reasonable?
Depends on the program.
Oh, it depends on the program.
How much memory do you have available? Do you care? Is it, like if memory isn't exactly an issue as much, then you can set that number to be much, much larger, right? But then if it's, you're really constraining, yeah, 50 or 20 past that, or 25, maybe, or even lower, like just depending on, yeah, yeah, but I guess if you're using it more too. If you have more operations, then it needs more memory.
So let's go back up a step. What is a priority queue as an abstraction?
Doesn't Java have an array that automatically grows and shrinks on its own? Like a DQ array?
An array list will grow, but it doesn't shrink. So, as an abstraction, how do you describe a priority queue?
So it would be like a collection of objects that are arranged based on priority.
And
Highest priority element gets up first.
right. And that describes the abstraction of priority queue, right? Notice what you didn't say.
Anything about keeping track of what was removed?
Yeah, you didn't say anything about keeping track of what was removed, right? So that priority queue abstraction doesn't include that, right?
So it's not in the definition of priority queue to have that feature.
Yeah, it's not a definition of priority queue to have a feature, right?
What can be an abstraction which can have undo feature in the definition?
Why would you want a priority queue to know how to undo itself?
No, I'm asking what can be another abstraction which can have that feature, which is in the definition of that feature. What can be that feature like?
An undo system, right? I mean, what else?
If it's a single abstraction you're trying to pick out, it should be its own class, right?
If a single abstraction should be its own class to build the stack inside, right? It also means the priority queue has to know all the commands, right? So all of a sudden your simple priority queue has gotten bigger, it's consuming more memory, right?
So you don't put the undo redo stack in the priority queue.
No.
Do it in the commands or whatever you decide to call it class. Because that's a function of the command.
So the command,
okay.
the command, it has to know what you want to change, right? And how you want to change it. What are you changing here?
You're sending.
What are you changing, right?
The queue.
You're changing a priority queue, right?
Does that mean then that you, like, for whatever, let's just say student objects, because that's what we're working with in the assignment. I mean that every time you remove a student object from the priority queue to implement the command, you have to create some copy of it and then fire it over to the command class, whatever, like whether it's a stack or whatever is implemented inside, to hold it over there for some prescribed amount of time until you save and close the text editor or whatever you're doing. And that would mean that if you want to redo it, you have to call back from the priority queue to the command class to put the object back in. So you need to look at these things like up and going at the same time together to get this functionality.
Wait. No. We just talked about what is the abstraction of priority queue, right? And no one mentioned anything about saving a history, right? Which means the priority queue doesn't know about history, right? So why should it know about undo? What's that? The question is where do the responsibilities go, right? In object-oriented systems, we build a bunch of classes that work together. And the question is, what responsibility goes where, right? And so we ask, what's a priority queue? Oh, a priority queue, right, we just keeps, it's a collection which stores elements that can be accessed by the highest priority, one at a time, right? You add things and remove things. And a few other things, maybe we'll get size and that sort of stuff, but that's what a priority queue is. We're done, right? We implement it, that's our building block. Now we want to be able to maintain do undo, right? Oh, so now we have to decide, are we going to use a memento pattern or the command pattern? Oh, we decide a command pattern. So now we need commands. What commands do we need? Oh, the only thing that changes the priority queue are add and remove, right? You know, calling size on the predicate doesn't change it. So undoing a call to size doesn't mean anything because it doesn't change the priority queue, right? So we need several commands, and now we have to ask, right? If I do a remove, what information does my command need to redo that, right? That's the command's responsibility. What do I need to do to undo that remove?
You need access, in the context of priority queue, the command class needs access to the functions in the priority queue class, because it's going to have a copy of the object that was removed, presumably. And if you want to undo that remove or redo the addition or something like that, you are going to call from the priority class the priority queue enqueue function and give it the object in the stack to put back. Does that make sense?
Where does stack come from?
From the command class.
What stack?
What's what?
What stack?
So the command class doesn't handle the stack, it's represented the command stack, but
Do you see any reference to a stack here? Again, if the stack's inside the command, how many commands do you have? There could be 50 commands, right? Each one have a stack? How does one command know about the other command, right? Again, you have to think, we're building blocks, right? And we have to ask what's the responsibility of each one, right? Responsibility of each command is just to know, in this case, how to do an action and how to undo that action. We're done, right?
So are we talking about only one action here?
Yeah, one action, right? I add student 1, right? Okay, I create a command. Here's a student object. Here is the priority queue. Execute, right? How do I undo that? Well, I have to remove somehow that particular student, right?
Yeah. And we are not looking in the history. We're just concerned with this add.
Right. It's a single thing, right?
Single action.
So it's a series of operations to redo it without actually storing something. Right?
It's a single command, right? It's one operation.
If you're adding 2 students and you're doing the undo, only the latest one will be removed.
Well, a command can undo its operation, right?
I just want to validate what I understood is correct. So client will send if it needs to add an element or remove an element and which element. And concrete command class will take care that after adding what all it needs to do and after removing what all it needs to do. And the add and remove operation will be actually called from the priority queue. Is that right?
Say that again.
So client will send that I need to do operation on this object. And what operation? It will be add or remove.
Right.
And then execute will do all the extra things that it needs to do before adding or removing. And the add remove is handled actually by the priority queue. So is that right?
Yeah, I mean, how can I add something to priority queue? Remember, it's a building block, right? I build the priority queue. Now I can build a command. How do I add something? Well, I need the priority queue, and the priority queue has an add method or whatever it's called, right?
Is the one-to-one mapping between action and execute or one-to-many? Like there can be many actions and one single execute.
Each command represents one action. Now, one action may require a bunch of sub-actions, but usually it's just one action, right?
So when we perform an add action, the execute will be
So the question is, what do you do when you undo a add? How does, what do you have to do to undo an add? If you do another add, it doesn't undo it, right?
So our execute will be opposite of our action.
Your undo is opposite, has to undo the operation, right?
So I'm kind of confused on do you make the command able to just handle explicitly like priority queue, or would you say it's like a collection and you know that a collection has an add and a remove, so that you can use anything as long as it's implemented that command. How would you know when you're executing something? What if it wasn't this add and remove, right? Like what if you wanted to execute something different? Let's say you need the opposite, right? Like what we're doing right here, if you add something and we want to call remove temp to it, then how would you know if that is something?
Yeah, concrete commands are very specific, right? I want to add text to a document, right? So there'll be a command, just add text, period, right? I want to change this text from normal text to bold, right? That's an operation you do. And if you want to undo it, then you make a separate command just for every different operation you can do on the text that changes the text. You will need a command. Otherwise, how can you undo it, right? So commands are very, very specific to a particular situation, right? I'm going to add text, delete text, change the font size, right? Anything you can do, right, to change that text, and you want to be able to undo that operation separately, you have to have a separate command just to do that particular operation.
That command can be a function inside that concrete command class which we execute to do specific thing.
Yeah, I mean, that's what execute does, right? It calls a particular action on the receiver, right?
Okay. So priority queue has both add and remove function in the priority queue, and undo can call remove from the priority queue.
Oh, yeah, I mean, yeah, again, we build a priority queue as a building block, right? And now we're going to use it in our program we want to undo. And so we have a command, right, to do the operations indirectly, but we still, right, use a priority queue.
You still need a stack to keep the history of the undoable commands, right?
Yeah, but that's not the command prop.
It's not in there, right?
No,
It's
no.
not in the priority queue.
No,
Right?
it's not in the priority queue and it's not in the command, right? Yeah, it's a separate thing, right? It's its own abstraction. It doesn't belong here because each command doesn't know about the other command, right? So how can we put it in the command? So the text talks about various times when you want to do this. Right, action is a parameter. This is basically a callback, right? Now, if you just want to call back, right, often a lambda can replace a separate object, right? Because if the lambda is actually a closure, when you create the lambda, it can capture the receiver without having to create a separate class, and then you can just call a particular function on it. Now, if you need more information than that, then you may have to go to a full class. I mean, you want to add things at different times, right? You want to specify, here's what I'm going to do, I'm going to do it later. Undo this example. logging changes. Oh, and then we can have separate commands, and then in the command, it actually does several things. One is, oh, it can do the actual operation, but it can also then have a separate logging function, so you don't have to put, right? Yeah, we can build up higher level operations on primitive operations. Let's see, what's an example of that? Well, maybe you want to build up a small little language to do various SQL-like operations, SQL, right? Maybe you want to build an application for a manager to do some simple operations in the database and create reports. So we have the basic SQL statements that we can build various commands that do various types of operations, right, for them, and then we give a menu, like here's the 10 things you can do, right?
Or maybe while adding elements, we can generate unique IDs for that and then add them. Generating unique ID can be a high level operation on top of adding.
Yeah. In transactions, right? How do you actually implement a transaction? You ever know what a transaction is? And the problem is you do a bunch of steps, right? And then, oh, something went wrong, so I need to roll back all the, how do I do that? Well, if each one of the steps you do is store the command, then when you get so far, you're like, oh, I'm sorry, but we can't go forward, so let's go backwards. Well, you've got your commands with the undo, right? And you got your stack, so you can roll things back. Right, and so we have transactions, just something that it's an easy way to implement that transaction, right? Because you need to recall all the operations that are already done on the transaction, unless you want to copy it, or you can copy the entire state before you start the transaction and then just replace the state. But you're not going to copy the entire database, right? No, it's not going to work very well. So you need to be able to actually undo various operations some way. Creating a little language, right? Here are the various operations you want to do, and each operation you want to do in this little language, we create a command for, and then we can have this language where, do these various operations, and then we can just, when you write your program, you just store each command, and then when you execute, right? All the commands.
What about let's just say for example, I understand what you mean when you can redo if you're adding something, but let's say we want to undo the remove. So I think like one of the person said, right, you would have to store all those data types if you did like 1,000,000, and then let's say theoretically they removed all the way until like the last one, then re-add it again, and then if you want to do the undo, you had to have that data somewhere to reference to go back and undo the remove.
Right.
If you're adding them, and then but you can't. You're not supposed to store that in the command class. You're supposed to store that somewhere else.
Right.
And you just call it storage.
Well, there's another pattern called I forget the name in the moment. We'll talk about it later, but there's a separate pattern which stores them for you. I think. I actually should have worn my Prevailer T-shirt. So one example of this is in-memory databases. Anyone familiar with that term? Yeah, and they're becoming more common because they're a lot faster, right? Even when you're using solid-state drives, memory is a lot faster. And particularly in the financial world, I mean, you know that there's a company in Chicago that laid a fiber optic cable from Chicago all the way to New York. Why? Because they could do it shorter than the existing cable, and it gave them, you know, maybe a millisecond faster response time doing orders in the New York Stock Exchange, and that meant millions of dollars. It was worth their while to hire a company to lay a fiber cable all the way from Chicago to New York. That's expensive, but it was worth their while just for that time, right? So these guys, time really is money. It's big money, right? So having your database in memory is almost a must, right? Because it gives you better response time. The problem is, what happens if something goes wrong? Your machine dies, right? It crashes. Oh, your data's all gone. Oh, bad idea, right? So what do? One way to handle it is each time you do a operation, right, on the database and memory, you do it with a command, and then you save that command as a in some form on disk, right? And you basically have you have one file where you're appending this command object in some form. So what happens if the machine goes down? You just, at some point, you take a snapshot of the data, right? And then you have a history of commands, and then you replay those commands. And then when that history of commands becomes too big, at some point you take another snapshot and then reduce the commands, right, to 0, and you start over again. And so one of the first in-memory databases was created from this guy from Brazil a long time ago, before people were thinking about this. And he was like, well, I'm 10,000 times faster than Oracle. And he was, because it's all in memory, right? And you can basically do this writing on a separate thread. And so basically, high performance, right, is much, like I said, 10,000 times faster than Oracle. Yeah, so consequences, right, it decouples what you want to do. I mean, you got this third party, right, extra layer. It's either commands you don't have to modify existing classes. You don't put the command inside the priority queue, because to do that means you have to change your priority queue, right? It's a separate thing, right? You can make commands into composite objects like transactions. Now, one problem is that it means for everything you want to do, right, you're creating another class, right? But a lot of times, the only difference is the receiver and the operation you want to do on it, right? That's it. And so, after you've built your 30th or 40th command classes, like, I'm just repeating myself over and over again. It's boilerplate code, right? The receiver and the operation. So what do? Make a pluggable command, because, the receiver is easy to have. That's just a property or field, right? And then, which operation to do? We've got lambdas. I could pass in to a generic command object the lambda to perform when you want to execute, right? No, I forgot. I shouldn't.
So using one command class, you can do both priority queue and, for example, stack. Push and pop here and queue and queue here. Using one command class.
Well, the question is, in practice, can we do that or not, right? There are situations where that's not going to happen, because the things you may want to do are too specific, right, and are too detailed. But for a common situation, yeah, it's just you want receiver and the method to call.
You can just map depending on the receiver what you have.
Well, you just pass in you just give the command a lambda to actually do it, right? Now it gets more complicated when the method you want to call on the receiver needs arguments, right? No, now the lambda has to be the right lambda, and so there are times it doesn't work out right, but
all these arguments can be stored in the memory stack. Separate, like not in a command class. In the memory stack, just keeping track of all the operation changes, the object, what is changing, how they're changing, and what is the way to go back. If you're keeping track of all of that, then it should also keep track of the attribute that's required, that's needed for that change.
well, but you worry about this with storage. You have to also worry about the lambda has to know what to do, and you need to pass that set of arguments into your generic command. And so now your generic command has to know how to handle arbitrary arguments of arbitrary type. Oh, in Java, that's getting hard, right? Because no, arguments have to be, there are ways of doing it, and it's really ugly. You can use reflection. Lambdas make it a lot easier, but as soon as you start doing reflection, oh man, here's a receiver, your method, and your arguments, and this is really ugly. It's easier to do now. We've got lambdas, but still you have to worry about the argument list. What arguments do you want to pass in?
If you're working with stack, you have to pass it into the command.
What's that?
If you're using a stack to hold like previous states, you have to pass it into the command constructor or somewhere.
So if I'm using a stack to maintain a history before undo, why would the command need to know about that? What? If the command knows how to do something to undo it, right? Why should you have to know that it's stored in a stack someplace, right?
What should command do? Where, on what object should command perform? It needs the data, right, to do the operation.
Right.
So that comes from the stack, on the top of the stack. Okay, here's the data, do this. And command does that for us. And that's how we do undo.
No. The command keeps a reference of the data it's going to operate on.
So the command is keeping the reference stack. The stack, stack is not in the picture.
The stack maintains a history of command objects.
But this stack of command objects is itself a separate class.
It's done somewhere else, right?
Right, so it's not like on the operating system stack, it's on command stack somewhere else.
Right.
Class command stack. So you call a command, copy of it gets thrown to the command stack, and then that also stores the undo and redo commands. And then if you ever need to do that, you just go over here and say, hey, what was that thing we just did or undid?
You don't care.
Exactly.
You just pop a command object off the stack,
Right.
call undo.
Right.
Gone, right? So you don't have to worry about re-assembling the command object from the raw bits. You just.
There are three things in the picture: priority queue, command, and stack. Yeah. So everything done on the priority queue, add or remove, or on the undo, add or remove, goes in the priority in the stack. Like, okay.
So you're talking about the assignment, right?
Yeah.
So there's a priority queue over there. There's a bunch of command classes over here, right?
Or undo.
And then we do an operation. Oh, I want to add something to the priority queue. I create an instance of my add command, and it needs a reference to the priority queue. It needs to know what to add, so you give it a student object, right? And then to add, you say execute. And then we take this thing and we put it in the stack, someplace over here.
So the command is doing the add. Priority queue is not doing the add.
Oh, no. What do you mean? I call execute on the command. It can't, we don't give the command internal access to the priority queue operations, right? We give it access to the public ones.
Yeah, it has no add and remove functions. The
Yeah.
priority queue has that already.
And so the command calls the add function on the priority queue.
Yeah. In case of undoing that, just if you want to undo, then the command class calls those functions. Like if it is add, the command will call remove. If it is remove, then the command will call add.
On the priority queue,
On
yeah.
the priority queue.
Data and operations.
What's that?
Data and operations.
Data and operations, right. And what is the abstraction, right? We figure what the abstraction is, build that out, that's the building block, right? Priority queue is one abstraction, commands are another abstraction, right? Maintaining the history of operations is something else. When you start trying to combine them all together, things get really, really complicated, right? If I'm going to build it all in the priority queue has to know about commands, right? And so all of a sudden you have all the commands, but the problem is we don't know what commands it's going to need because we don't know what we're going to put in there, right? And so we build it. How can the priority queue actually create the commands? It can't because today it's students, but tomorrow it might be something else, right? And so it becomes difficult. We could make a generic command, but all of a sudden the priority queue is getting more complicated, and then it has to have a history. And then you have to worry about the size of the thing and what happens when you don't want a history when you build it, right? And what if you don't want the command? If you don't know the history, well, why the commands? Why are you creating these commands? So why are we tying all this priority queue stuff to things that may not need? So keep them separate.
Doing this way, really emphasizing like the whole practice of object-oriented programming to begin with, right?
Yeah.
And just like putting everything in the main function and just kind of lobbing it together. There's actually like a methodology here.
Right, it's object-oriented programming, right? The goal is we find abstractions, we transform them into classes, we use those classes as building blocks.
Just make them talk to each other.
And you make them talk to each other, right?
All they do is what they know how to do, and it just goes.
Right. There's this. As things get more complex, right? No. Effort required, right? As they're simple, it's not that hard, right? But as things get more and more complex, it takes more and more effort, right? And so you want to stay down here, you don't want to go over here. And so the idea when object programming is, we're going to build a priority queue. It's not that hard, right? There's some complication. You have to worry about doing this, but it's not that hard, right? Commands are not that hard, right? Implementing a stack to keep the history is not that hard. But you want to do it all at once, that pushes you further this way, but the effort goes up, right? It's easier to build a bunch of small, we don't know like the exact nature of this curve, but it's not linear, right? And so being able to do 3 things down here and then using to combine them is going to be easier than doing one thing out here. So yeah, that's what I said, right? When we started the course, I said, oh, what's object programming? Oh, it's, I said this like in the very first day of class, right? Object programming, a program is you build a bunch of objects and then connect them together and say go, right? And once you understand that, then it becomes whose responsibility to do what, right? How do I break these responsibilities down to separate abstractions that can build up in the classes? And so this, pluggable command is a nightmare. In Java, it's a little easier with lambdas. In Python, it's going to be easier. Right. So here's an example of pluggable command using lambda. Did I go too far? Yeah, pluggable command. Yeah, here as well. You have to store, two commands. And I can pass in the two commands, and I don't show you how to pass arguments, but it becomes a lot easier with lambdas to actually build a pluggable command. And then I can pass in, create two lambdas, pass them in. Yeah, in Java lambdas, there are some tricky restrictions, and so it's harder than it should be, but if you're using Java, you should be used to. When Java first came out, they were saying that Java made hard things easy to do and easy things almost impossible. Once you start using lambdas, you can start replacing commands with them at certain times, right? For callbacks, right? If you're a JavaScript programmer, and you use Node, you use callbacks all the time, right? Everywhere, but you don't use commands. You just use lambdas. Why? Because all you need to know for simple things, you just need to know the receiver and what to do on the receiver, right? And you can put that into a lambda and then just pass that around instead of having to create a separate class, right, to store that. So one of the things early on in the command with the pattern movement, one of the influential people in the algorithm programming community was dissatisfied because he said, you guys are talking about you're building up this pattern language, but I don't see a language. I just see a bunch of random patterns. And he said, not only that, but what I'm seeing is you're just covering up defects of your language, right? He spent most of the time doing list programming, and just like a lot of your patterns you're doing are just because Java is a crummy language, and you're trying to make it get over some of these difficulties. And so one of them was like, yeah, if you have lambdas, right, from the beginning, a lot of uses of the commands go away. Need for the commands go away. We can just use lambdas. And there are a number of patterns you'll see that with. Okay, as soon as you've got this particular feature in a language, well, this pattern, the need for it reduces, right? And as we're going forward in time, right, more languages are coming out with different features. And so then you have to ask, how does a language affect each pattern, right?
Command pattern does not store previous states, just the command itself to get to that state, right?
A single command just worries about executing one operation, yes.
Saving states is that other type of design.
Well, now we get to do some implementation details. How do you undo things? There are some operations which don't have an inverse, right? In that case, you have to copy the previous state, right?
Is that a closure?
Copying the previous state? No.
Because it doesn't store like local variables, it's just making a copy of the data structure, and it doesn't care about the environment, it's just the previous data structure arrangement.
Well, the problem is if your closure captures that variable, it has a reference to it. The question is, copy it or have a reference to it? Have a reference to it, you change it, it has reference to the changed one.
Exactly, yeah. So you have to make a copy, like a separate copy of it.
Right.
Okay. And that's the problem with the priority queue, since you have to keep it in a certain order. If you add something to it, it shuffles the order, so you have to copy the previous state.
Well, the question is, how important is the order?
Whenever something gets added to a priority queue, you have to keep a fight to get the largest element to the top, no matter what.
Right. So I guess you could just make the copy before you keep a fight, and you always know that it's going to be in the back. You enqueue the thing, you enqueue, if you want to undo and enqueue, copy the state before it's reheapified, and then you just pop the remove the thing from the back of it.
Yeah, so now you're coming. Design patterns are talking about the concept, right? But when you implement them, you may have to modify them a bit, but you have to worry about the implementation details, right? How do we actually do undo? Well, it depends upon the actual situation, right? Some operations do have a clean inverse, some don't. Yeah. Yeah. And so it turns out, yeah, we can actually do this. Closures, functions can hold state, right? We've seen this example. So we're going to do this. The functions can main state. And you can do some tricky things, right? So I can build a type which contains two functions, and I can pass that type around, and so you start to see these languages start to do either remove the need for that particular pattern or change the need for it, or we can start doing it in different ways. And I think you've probably been around long enough to realize that in your career, you're not going to be programming in the same language for the next decades, right? Well, I've probably confused enough people for one day.